My camera's saying, man, shut up. Alright. How are we feeling about it? And this is not necessary. This is a little shortcut. If you like it, you can use it. If you don't like it, like I said, you can just do all the borrowing and that's fine. Nothing wrong with that. Okay. Same thing. But this is a little quicker, and that's really quicker. So if I said, what's 1 minus 0.7921793.6? I would just go, make that 9, 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 make that 10. Done.
Oh, I like it.
Now, if you didn't get that, it's okay. I explained why it worked. But if you didn't get it, it's okay. It's a shortcut.
I like it.
Okay. No, both of you. Shut up. Alright. Alright, okay. So that's addition, subtraction, decimals. Again, the shortcut is not necessary. It's just, I just want to show it to you because it exists. That's cool. Who remembers what it is about multiplying? And let me show you an example of why we have to do this the way we do it. So, for example, what is 0.2 times 0.2? Well, let's look at, oh shit. Go with me for a second. I know a lot of you guys know what to do. I'm going to show you on the side the reasoning behind what we do. What is that as a fraction? 2/10. So it's 2/10 times 2/10 is, don't go there, is what fraction? 2 times 2 is 4. 10 times 10 is 100. And what does that look like as a decimal? 0, 4. I'm going to stop there for a second. But some of you guys might remember, what you do first is you forget there are decimals there. You just multiply the numbers, and then you got to go back how many places? 1, 2. You count the total number of places in the problem. Why does that work? Because it relates to how many 10s you got, so you're going to collect them all together, so at the end you go the right number of places back. That's why it works this way. So I'm going to take 4, I'm going to go back 1, 2 spots. And that's how I get 0.04. Let's do another one together. You guys see what I mean by 10 times 10 is 100. So this is 1 10, another 10, so I get 100. I got to go back twice, because that's what would happen if I made them into fractions. I'm not saying do this. Please, dear God, you shouldn't have to. But that's why it works. So if I had, instead of this, if I had, let's say, what do you got, Jeff? I don't know, man. 1.03 times 0.7. Sure, I like it. So you just treat them as if there's no decimals, like it was 103 times 7. See, I don't have to line them up either. Remember, multiplication doesn't require like terms, which is really why lining them up is lining up your like terms. Do you see that? Like, my 10s have to be lined up, my 100s have to be lined up. Multiplication doesn't need that shit. Right? 7 times 3? 7 times 0 plus 2? 2. 7 times 1?
2.
How many places do I have to go back total? 1,
2,
2, 3. 1, 2, 3. 0.72. Why does that, now think about it on this level. Isn't that about 1? Isn't that 1? Basically, just a little bit. So what's 1 times 0.7? It should still be 0.7. But it's a little bigger than 1, so the answer is a little bit bigger than 0.7. So what happened? What's up? So is everybody cool with 721? Let's just multiply them like as if there's no decimals, right?
But then you put the decimal back.
1, 2, 3.
Oh, okay.
3 total places. Because this would be hundredths times tenths is thousandths. Do you see that?
I see it.
Hundredths times tenths is thousandths. But instead of saying that to yourself, it's better just to collect 1, 2, 3 total places, 1, 2, 3 total places. Kabam. So it's really just one extra little layer on top of normal multiplication. You just got to be careful about what place it ends up in. Okay. One little thing that I don't talk about too much, it just came to mind. Could somebody estimate what this would be. Estimate what that would be. And then I'll also see if you know how to. You guys are doing too much. Estimate should mean you don't write anything. Is what estimation means.
5.
Yeah, it's roughly 5, maybe roughly 5.5 even. I mean, you could say like roughly 10 times 0.5, which is 5. So 2 things came out of that. Estimation is awesome because then if your answer is 527.7, you know it's not right because your estimate was 5, roughly 5. Secondly, do you guys know if we multiply something by 10, what happens to the decimal place? What's 10 times this? You should not need a calculator.
1 or what? 3. Yeah. Okay.
It's 0.03. In fact, we already know that. What's 10 times 4.0? What's 10 times 4?
40.
You moved it over, didn't you?
Yeah, I did.
It's the same thing we always do. We always do that. So why suddenly change? You guys, I never do that. Yes, you do. You just don't realize it. So just look at this a little deeper. What fraction is this? Thousands, right? Can't I cancel 110? So is it now 300ths? So didn't it just move over 1? So when you multiply by 10, you move the decimal over 1. Why does that make sense? Because our number system is based on 10. So when I multiply by 10, everything gets one place higher than it was. So it was in the thousands, now it's in the hundreds place. So when I divide by 10, the decimal is going to move the other way. What happened? Shit. So when I multiply by 10, the number gets bigger. It moves that way. When I divide by 10, it's going to get equally smaller. It's going to move that way. So if I had 0.907 divided by 10, make it smaller. So is it going to go this way or is it going to go that way? So it's going to become what number?
0.0907.
Yeah, just moves the decimal one place. If I multiply by 100, it moves it over twice. If I divide by 100, it moves it back twice. 1,000, 3. Divide by 1,000, 3 the other way. Why should it work so easily? Because decimals are based on 10, so when I multiply or divide by things that are based on 10, they just move where the decimal is. Of course they do. Maybe. So if I did 1,000 times 0.000711. Come on now. It's going to make it bigger or smaller when I multiply by 1,000. Bigger. When I multiply by 1,000, it should make it bigger. So the decimal is going to go 3 that way. Should make it a bigger number, right? 1, 2, 3. So now it'll be 0.0711. So when you multiply or divide by powers of 10, 100, 1,000, the decimal will move the same as the number of zeros there are. Which direction? It depends on if you multiply, it'll move to the right. If you divide, it'll move to the left. I'm really bad with directions. I always think multiply makes it bigger, so that's going to move that way. Divide makes it smaller, it's going to move that way. Well, that's a good question in itself. Which one of these is bigger? 0.09 or 0.9? Which one's bigger? 0.9. Good. That was a good place to start because I'm going to make this 0.90 and then it's really easy to compare, right? So that's one trick with decimals. If they're asking you which one's bigger or smaller, add zeros until they're equal after the decimal. And then you can say that's 9 and that's 90. Well, that's bigger. Shit. Right? Is that? So adding zeros helps you add, subtract, and it also helps you compare between the two. All right, so here, you guys do this here real quick here. Very quickly. Hurry up. That's gross. That's really gross. Ooh, that's so gross. Have fun with that. Let's see. Good deal. You're good? Okay. Just want to make sure you're right. Yeah, as long as if there's a fraction and then parentheses, fraction, you just multiply. Yeah, so let me write a little note on this. Exactly. Let me see, where was the... Ah, I see.
Because I will find in the factory, but once we got in the and this was we get married and we used to just multiple.
Yeah. So I put there, like on these problems, not multiply, because there's a plus and a plus, right? So you want to add those. Whereas on this kind of problem, you want to multiply, because they're sitting next to each other, right? There's no addition or subtraction in the middle, there's just a parenthesis, so that's multiplication. Change these to improper. It's hard to multiply mixed numbers. You make them improper fractions first. Well, not really. You want to do the opposite of that. You want to multiply and add. So like 2 and 2/5, you would say 5 times 2 is 10. Plus 2 is 12, so that's 12/5. Right, so that's doing the opposite. Sure. I got you. It all depends on if there's an operation in the middle or if there's no operation. If there's no operation, you multiply. Add the other top number, yeah, to make it improper. That's right. All right, guys. Let me catch up with you. So let's see. 3, 2, 9. That's nice. And then 0, 3, 2, 9 again. And then 0, 0, 6, 4, 18. Is that cool?
Yeah.
Yep. And then 0, 0, 0, 3, 2, 9 again, right? This is ones, just repeat the 923. So then you get, oh my God. So you get 3, 5, 17, 17 again, 11, and then 11. You're close? Okay. And now that's not the answer, right? Don't just start putting commas in. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1 point. Blah, 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 blah.
I did not. It's written right here.
Yeah, I went backwards.
You do that too well.
Yeah, that's a practice. Yeah.
Stop.
It's around the world back snap. There you go. All right.
Gee, Louise.
Is that cool? You guys see that? It's just
Yeah, but I thought you said on multiplication, you move your to the right.
no. When you multiply by some multiple of 10, multiply by 100, multiply by 1,000. Here I am multiplying 12
Right.
by a number that's way smaller than 1. So my result should come out smaller than 12. 12 times 1 is 12. 12 times 0.1 would be 1.2. So this 1.1 would make sense, because it's 12 times something a little smaller than 0.1. So don't take that to mean anytime you multiply anything, that happens. Well, I said if you multiply by a multiple of 10, so if you multiply 10 by 100 by 1,000, then your decimal will move. Yeah.
How about division? The same way by multiple.
Yeah. So if I divide by 100, how many spots will it move in which direction?
To the left.
How many zeros do I see?
2.
So it's going to move twice, and since I'm dividing, it's going to get smaller.
Right.
So that'll just be 0.410791. Please, dear God, not only do I not want to see it, but I might even take points off. If you set this up in a big division problem, my God, you got to realize this is just divided by 100. You don't need any work, really. Just move the decimal over. Is that cool?
Yeah.
All right. Jeff sees the spokesperson. There's nobody else that's saying anything.
No, I'm not the spokesperson.
All right. I'm sorry, Jen. I don't want to put that before fun. The only thing I heard was yes, so that's what I'm going to go with. If this would have been 41.0791 times 1,000, what would that have been? What happens then? Which way? I'm multiplying by a multiple of 10, so now it gets bigger, of course. Doesn't that make sense? If I divide, it's going to get smaller, it's got to go that way. If I multiply, it's got to get bigger, it's got to go that way. So 1, 2, 3, so it'll be 41,079.1. What is 40 times 1,000? 40,000. Isn't that about what I got? It's got the extra details in there, but it's roughly 40,000. That's estimation. This is roughly 40 times 1,000 is 40,000. That's about what I got. I feel pretty good about that. Okay, I like it. Just make sure you know where we are. This is section 5.2. Last thing for the day. Last thing. Dividing decimals. So some of you guys should know this already. But I'm curious if you know why you do this. So if I said divide 417.03 by 0.09 by hand. Do you guys know how that works? So if I say 0.09 into 417.03, who knows what it is you do there? Because I can't work with 0.09 very well. Good. So I got to move this one twice. So I better at the same time move this one twice. Now why? What the hell? Why can't I do that? Because some teacher in your past said to do it. But do you know why you're allowed to do that? Can I multiply the top and bottom of a fraction by anything I want to, as long as it's the same? Yes, Jeff, yes. You can multiply top and bottom by 7, by 28. I can multiply top and bottom by 0.344447 if I wanted to, as long as they do the same thing to the top and the bottom. Is everybody with me on that? That is a big time yes. Would I ever do any of what I just said? No. But watch, I can multiply top and bottom by 100. Why would that be a smart number to pick? Because that makes the bottom become a whole number. That's why it works. However many times you got to move that over, it's related to multiplying by 10 or 100 or 1,000. You move that the same amount over, so you're doing the same thing to the top as you are to the bottom. That's why it's legal. That's why that process works. And now you just got to divide 41,003 by 9. 9 gives them 41. 4. 36. 5, bring down the 7. 9 goes into 57. 6. 6 times 9 is 54. 7 minus 4 is 3. Bring down the 0. 9 goes into 30. 3 times. 3 times 9, 27. There's a 33. Bring down to 3. 9 goes into 33. 3 times. 3 times 9 is 27. Mine is equal to 6. And then I could, if I wanted to, tell you to go out to the whatever place. So see, do you remember that? Add on a 0.0 if you need to go further. So now you bring down a 0. 9 goes into 60. Please make it stop, Jeff. 9 goes into 60. See how I put the decimal there?
6. 6 times.
6 times 9, 54, minus equals 6. Do you see now what's happening here? 66. 6 times 9, 54. 66. 6 times 9, 54. 66. 6 times 9. So of course I just, say repeating, right? Sorry. I wonder if anybody thinks, oh, he's just gone. He's gone. He's gone. I knew it was headed that way. It's just happened. I was so happy I was here for that. Let's all slowly back away. All right. Is that coming back to you, this kind of stuff? Add on as many zeros as you need. You're going to see some that you're going to see a pattern. Please, dear God, if you see the same thing happening, just stop and put a bar over that. Bar just means, good God, it keeps going. All right, that's plenty. So we got to the end of section 5.2. So don't forget Thursday, the quiz, and then we'll just go further in 5, and I'll have the practice test ready to give to you. Just chapter 4. Yeah.
Oh,